Hey guys, in this video I will present a solution to Romania Team Selection Test 2012 Day 2 Problem 1. The problem is as follows. We shall prove that for any positive integer n greater than or equal to 2, the following identity holds. The sum going from k equal to 2 up to n of the floor of the kth root of n is equal to the same sum, so going from k equals to 2 up to n, of the floor of log base k of n. We see that in this identity we have completely different summands on the left and on the right side. Therefore, it would be difficult to compare them directly. What we want to do is to shift our perspective. A promising way to do that is, instead of summing all of those values for the floor of the kth root of n on the left side, we could just count for every possible integer L how often is this integer less than or equal to some summand on the left side, and if we sum this value all up, we're going to get an equal value. And hopefully this is going to give us exactly what we want. So consider some integer L such that L is of course greater than or equal to 2 because we want to end up on the right side, and assume that L is less than or equal to the floor of the kth root of n. Of course, since L is an integer, this is equivalent to L less than or equal to the kth root of n, which we can reformulate as L to the power of k is less than or equal to n, or k is less than or equal to log base L of n. So from all of this we see that those two functions are pretty much exactly inverses in the way we would like them to behave. Now, to finish our proof, we want to formalize that. And a very neat way for doing this, if we want to formalize a change of perspective, is double counting. And the quantity that we're going to double count in this case is going to be the size of the set of all possible pairs L, k in 2, 3, 4, all the way up to n, such that L to the power of k is less than or equal to n. And we call this quantity m. And we want to count the quantity m in two ways, and to do that we'll use those equivalence relationships. First, do it from the point of view of k. So m is equal to the sum of k equal to 2 up to n of all possible values of L in this set, such that L to the power of k is less than or equal to n. We have already seen that this is equivalent to L being less than or equal to the floor of the kth root of n. Now, the number of values L satisfying this and L greater than or equal to 2 is exactly the floor of the kth root of n minus 1, which is equal to the left side of our equality minus 1 times the number of summands, which equals n minus 1. On the other hand, we can count m by first summing over the possible values for L, which are L equal to 2 up to n, and then we have seen that L to the power of k is less than or equal to n if and only if this holds true, and for an integer k, this is of course equivalent to k less than or equal to the floor of log base L of n. So the number of possible values k for such an L, and such that k is at least 2, is exactly equal to the floor of log base L of n minus 1. Analogously, as in the previous line, we get that this is equal to the right hand side of our equality minus n minus 1. And this proves our desired equality, because on the left hand side we have an m in both cases, and of course minus n minus 1 equals minus n minus 1, so this sum is indeed equal to that one.